Welcome to another deep dive. Today we're headed to the coldest lap on Earth, 2.5 kilometers under the ice in Antarctica.
The IceCube Neutrino Observatory.
Right. You're obviously here because you're interested in learning more about neutrinos and how these tiny particles can help us understand the universe.
Well, neutrinos are fascinating, that's for sure.
So maybe we should start with a quick explanation for anyone who's new to neutrinos. They're like
Ghost particles?
yeah, ghost particles, because they can pass right through almost anything.
It's true. They barely interact with matter at all, so they can travel across vast distances from the most extreme events in the universe, like exploding stars and black holes.
And bring us information.
Exactly, without being absorbed or scattered like other particles.
Okay, so that explained why they're valuable. But why build something as complex as IceCube in such an extreme environment?
Well, to catch these neutrinos, it has to be huge and incredibly sensitive because neutrinos so rarely interact with anything. Think about it, over 100 trillion neutrinos pass through your body every second and you don't even notice.
It's mind-boggling. And IceCube can actually detect them.
It can. IceCube uses thousands of sensors embedded in a cubic kilometer of ice. Imagine a giant three-dimensional grid of incredibly sensitive light detectors.
Like a giant net trying to catch these tiny particles.
Exactly. And when a neutrino, on the off chance it does, interacts with the ice, it produces a faint flash of light. These sensors detect those flashes, and then scientists can reconstruct the path and the energy of the neutrino.
Okay, so we've got this amazing observatory detecting these ghostly particles. But the big question is, what can they tell us about the universe? I mean, some people believe that neutrinos could even help us understand the very fabric of space-time itself.
It's a fascinating possibility. One of the things the IceCube team has been looking for are violations of what's called Lorentz symmetry.
Lorentz symmetry?
It's kind of like a fundamental principle in physics that says the laws of physics should be the same for all observers, regardless of their motion.
So no matter where you are or how fast you're moving, the laws of physics should apply equally.
Right, but some theories suggest that at extremely high energies or under extreme conditions, Lorentz symmetry might break down.
And that would mean?
That would be a huge discovery. It would suggest that there's new physics beyond our current understanding, perhaps even hinting at a theory of quantum gravity, a way to unify Einstein's theory of relativity with quantum mechanics.
So how do neutrinos fit into all of this?
Well, because neutrinos can travel across such vast distances from these extreme environments, they're the perfect particles to test for violations of Lorentz symmetry. Even the tiniest deviation could be a sign of something new and groundbreaking.
So they used IceCube to look for these tiny deviations. How did that work?
Neutrinos come in 3 different flavors: electron, muon, and tau. And as they travel, they can actually change between these flavors, a phenomenon called neutrino oscillations.
So they're kind of like chameleons, changing their appearance as they go.
In a way, yes. And by analyzing 7.5 years of data from IceCube, focusing on the ratios of these different flavors, the researchers could look for any anomalies, any patterns that didn't quite fit with what we'd expect if Lorentz symmetry holds true.
So did they find anything? Did they find evidence that our understanding of physics is incomplete? Did they find a clue to this quantum gravity theory?
That's where it gets really interesting. They didn't. They didn't find any deviations from Lorentz symmetry.
So a null result.
Exactly. But even a null result is valuable. It's like eliminating a suspect in a mystery. It helps us narrow down the possibilities and refine our search.
So it's not that they didn't find anything, it's that they found out that if there are any deviations from Lorentz symmetry, they must be even smaller and more subtle than we initially thought.
That's a great way to put it. It means we need even more sensitive experiments and even more data to probe these deeper mysteries.
It's like the universe is daring us to find these tiny cracks in our understanding.
And that's what makes science so exciting, this constant pursuit of knowledge, this drive to push the boundaries of what we know. It's what keeps us going. It's a challenge, but one that physicists are definitely up for, I think.
So we've been talking a lot about this fundamental physics research, but what about the bigger picture? I mean, what else can neutrinos tell us about the universe beyond space-time?
Well, that's the beauty of neutrinos. They're not just about testing fundamental physics. They're also messengers from some of the most extreme and energetic events in the universe.
Like what?
Well, for example, neutrinos can provide unique insights into blazars.
Blazars.
Yeah, imagine a supermassive black hole at the center of a galaxy actively devouring matter. And as this material falls into the black hole, it forms a swirling disk. And some of that material gets blasted out in these powerful jets of energy and particles traveling at nearly the speed of light.
So we're talking about incredibly powerful events.
Oh yeah, extremely powerful. These jets can extend for millions of light years. And when one of those jets happens to be pointed directly at Earth, we call that object a blazar.
Okay, so we're talking about understanding these incredibly powerful events billions of light years away, all thanks to these tiny, nearly invisible particles.
Exactly. And it's not just blazars. Neutrinos can also help us study the conditions at the very edge of the observable universe, potentially giving us clues about the earliest moments after the Big Bang.
It's like having a time machine.
Yeah, you could say that. Each time we detect a neutrino from a distant source, we're essentially capturing a snapshot of what the universe was like billions of years ago.
Speaking of capturing neutrinos, this whole IceCube Observatory is a remarkable feat of engineering. And how do they even build something like that in such an extreme environment?
Well, it's a massive undertaking requiring ingenuity and collaboration on a global scale. They use specialized hot water drills to melt holes deep into the Antarctic ice sheet, 2.5 kilometers deep, to be exact.
Wow, that's deeper than some ocean trenches.
It is. And then they lower strings of incredibly sensitive light sensors called digital optical modules down into these holes. These sensors are spread out over a cubic kilometer of ice, forming this massive three-dimensional grid.
It sounds like something out of a science fiction movie.
It really does, and the fact that they can maintain this facility and collect data year-round in such harsh conditions, freezing temperatures, constant darkness for part of the year, it's really a testament to human ingenuity and our thirst for knowledge.
It really makes you wonder what other incredible discoveries are waiting to be made. I mean, if we can build a giant neutrino detector under the South Pole, what else is possible?
That's the beauty of science. There's always something new to discover, always another mystery to unravel. And as we push the boundaries of what's technologically possible, who knows what incredible insights await us.
So we've talked about how neutrinos can help us understand fundamental physics and extreme cosmic events. But is there any practical application for this research? I mean, does understanding neutrinos impact our everyday lives?
Well, that's a question that comes up a lot, and it's a valid one. It's not always immediately clear how fundamental research will translate into practical applications, but history has shown us that breakthroughs in our understanding of the universe often lead to unexpected technological advancements.
Like how studying the properties of light led to the development of lasers.
Exactly. And who knows, studying neutrinos might lead to advances in fields like astrophysics, particle physics, and even computing. For example, some researchers are exploring the potential of using neutrinos for communication.
Wait, really? How could you use neutrinos to communicate?
Well, because neutrinos can pass through virtually anything rock, water, even the entire Earth, they could be used to send messages through solid objects or across vast distances in space.
So we could potentially communicate with submarines deep in the ocean, or even send messages to other planets using neutrinos.
It's a fascinating possibility, though, still very much in the early stages of research, but it highlights the potential for unexpected applications to emerge from fundamental research.
It makes you wonder what other secrets these neutrinos are holding. I mean, we've only just begun to explore what they can tell us about the universe.
Exactly, and that's what makes neutrino research so exciting. There's this sense of wonder and discovery that comes with studying these elusive particles, and every new piece of information we gain brings us closer to unlocking the secrets of the cosmos.
So what are some of the biggest unanswered questions of the neutrinos that scientists are still trying to figure out?
Well, one of the biggest mysteries is their mass. We know neutrinos have mass, but it's incredibly small, much smaller than any other known particle, and we don't yet understand why.
So it's like a cosmic puzzle trying to fit these tiny, nearly massless particles into our existing models of physics.
Precisely. And then there's the question of whether there are more than the three known flavors of neutrinos. Some theories predict the existence of sterile neutrinos, which would interact with matter even less than the three flavors we already know about.
Sterile neutrinos, so even more ghostly than the regular kind.
Exactly. If they exist, they could have profound implications for our understanding of dark matter and the evolution of the universe.
So there's still so much we don't know. It's almost overwhelming to think about all the mysteries out there just waiting to be uncovered.
But that's what makes science so exciting. It's a never-ending journey of discovery, and with facilities like IceCube, we're getting closer to answering some of these fundamental questions about the universe and our place within it.
Yeah, it really is humbling to think about just how much we still don't know. It's like we're just starting to peek behind the curtain.
Yeah, and neutrinos, with their ghostly nature and their ability to travel across vast stretches of time and space, give us a unique way to probe the universe's deepest secrets.
Okay, so we've got these amazing particles that can potentially tell us so much about the universe, but what are some of the challenges that scientists face when studying them? I mean, they're so elusive, interacting so weakly with matter, it must be incredibly difficult to detect them.
It's definitely a challenge. That's why facilities like IceCube are so remarkable. It requires cutting-edge technology, ingenious engineering, and a really deep understanding of both particle physics and astrophysics to even have a chance of catching these ghostly particles.
So it's like trying to find a needle in a cosmic haystack.
I'd say it's more like trying to find a specific grain of sand in a desert. And even when we do detect a neutrino, it's just this tiny blip of light. Extracting meaningful information from that signal requires sophisticated data analysis techniques and a lot of computational power.
So it takes a global village of scientists and engineers to pull this off.
Absolutely. Projects like IceCube involve researchers from all over the world working together, sharing their expertise and resources. It's a real testament to the power of international scientific collaboration.
All driven by this shared curiosity, this desire to unravel the mysteries of the universe.
Exactly. It's this pursuit of knowledge, this yearning to uncover the secrets of the cosmos. It's a force that unites scientists across borders and disciplines.
As we wrap up our deep dive into the world of neutrinos, I want to leave our listeners with one final thought. If we imagine a future where we've unlocked even more of the secrets that these particles hold, what might that future look like? What possibilities could it open up?
Well, the possibilities are truly mind-boggling. Imagine a future where we can use neutrinos to map the interior of stars to study the very heart of a supernova explosion, or to peer back in time to witness the first moments after the Big Bang.
It's like having a window into events that have been hidden from us for billions of years.
Precisely. And who knows what other applications we might discover as our understanding of neutrinos deepens. Perhaps one day we'll even be able to use them for interstellar communications, sending messages across vast cosmic distances to other civilizations.
Wow, that's an incredible thought. It makes you realize just how much potential these tiny, almost invisible particles hold.
It really does. The universe is full of wonders, and neutrinos might just hold the key to unlocking some of its most profound secrets. So keep looking up at the stars, keep asking those big questions, and never stop exploring.
Because who knows what amazing discoveries might go waiting just around the corner. Thank you for joining us on this deep dive into the world of neutrinos. Until next time.